Chapter 4. Chapter 4 is a very, very good PowerPoint. Unfortunately, it's largely tied to formulas and powers of 12 and Texas Instrument calculators, none of which we're going to do in this class. So, the theory is excellent, but the actual hands-on practice where you roll up your sleeves and learn how to do the equations leaves something to be desired. So, a couple housekeeping points. We are going to use Excel for the time value of money. And the time value of money is fundamentally important for about the next 4 modules. So we want to get this right. What I'm going to do is I'm going to be starting off with the flip charts, and then we're going to go to Excel and plug this stuff in. And I think you're going to find that a lot less stressful. Assuming, and this is a huge assumption, assuming that all of you have been divided into groups, and I hope by the time you see that, this has happened. The first quiz, fingers crossed, will be a group quiz where you can work with your other group members. Okay? If we haven't divided all of you into groups by the time we get to this module, and we're in Module 3, Chapter 4. If you're not already in groups, you're going to have to do the quiz on your own. But if we've got you divided, this first quiz you can work together as teams. Hope that helps. Now, time value of money. Here's the assumption. The value of $1 now is worth more than the value of $1 a year from now. In its simplest form, that's the time value of money. Okay? So that's our premise. That's where we're coming from. If we understand the time value of money, then we understand that if someone promises to pay us money in 1, 2, or 3 years, we could have invested that money in the bank right now and earned interest on it. Now, admittedly, we're not earning a lot of interest these days, but that's not always been the case. And you'll see from a lot of the examples we use that in years gone by, we expected much higher returns on our money. What that means is we can have money today equating to a bigger amount of money in the future, and vice versa. Money promised to us in 2 years is going to be less than that amount if it's given to us today. That's the difference between present value and future value. The hardest thing to do in this class is to figure out what we're solving for. But I've got a solution for that. I always use a timeline. And the timeline starts off with present value, ends up with future value. It has an interest rate. It has a number of years or term, and sometimes it also has payments. If we know some of these, but we're missing one, that's what we have to solve for. And Excel allows us to solve for any of these. So, let's do it very simplistically for starters. I want to invest $100 today. I don't know what it's going to be worth in the future. It's going to be invested for 1 year at 5% interest. And payments don't count because there aren't going to be any payments. So the term is 1 year, the present value is $100, and the interest rate is 5%. I'm solving for the future value. Well, I don't need Excel to show me this. All that I have to do is say, what's 5% of $100? Well, that's $5. I add $5 to $100. In 1 year's time, I know intuitively this is going to be worth $105. The exact same thing would have happened if I'd done this in reverse. If I said, I will give you $105 a year from today, the interest rate is 5%, and it's for 1 year, what's the present value? I would divide 105 by 1 plus the interest rate. In this case, the interest rate is 5%. So it's 105 divided by 1 plus 0.05, or 1.05. You can do that one in your head too. 105 divided by 1.05 is $100. So, I guess we're done. We understand present value and future value. Well, unfortunately, we're not done. We're going to be seeing how to do a little bit more elaborate calculations than this, but this kind of whets your interest as to how we want to go about this. Now, you can take this many, many steps further, but the most common way that people begin to get a sense for the power of using these formulas is when it comes to buying a house. Okay? If we find a house that we really like, and we know that we can put down $100,000, and the cost of the house is $300,000. So we basically need $200,000 to buy our dream house. Okay? The interest rate is going to be 4.125%. The term is going to be 30 years. And we need to figure out the payment. All of a sudden, this isn't as simplistic as it was before. We realize that we can't just do this stuff in our head. We're going to have to basically have something that is better than, the old days people would do this on these long spreadsheets. We need something that's much more straightforward, and that, of course, is Excel. By the way, we're not going to solve this one immediately. We're going to kind of spoon-feed our way up to being able to solve this, but within about 15 minutes, we will be solving this. Okay? Let's just hide this for a moment. Now, present value, future value. There are other things that we can solve for. We can solve, for example, for payments. We can solve for even cash flows and uneven cash flows. What we're going to do is, in today's lesson, we're going to focus on even cash flows. In the next lesson, we'll focus on uneven cash flows. And, of course, Excel can handle both of these. All right. So let's take a look. We've got a timeline. We are getting payments of $100 a year. And we're getting those payments for 3 consecutive periods. And we're wondering what the future value of $100 a year for 3 years is going to be. The interest rate is 6%, and we can see that the number of periods is 3. We don't have anything to begin with, so the present value is 0. What are we solving for? Well, we're solving for the future value. So you can solve for future values for 1 period, or you can solve for 3 periods. Let's use this example, and I'm going to actually disappear from the screen and go over to the main computer, and we're going to show how in Excel we can solve for different things. Okay? So magically the screen is going to appear. Unfortunately, I'm going to disappear for a moment. if you can see the screen, and I hope you can, put your, open up Excel, click on any cell, and then at the top left part of the Excel screen, you see FX. That's calculating formulas, FX. So I click FX, and all of a sudden this drop-down box appears. And the top box says, type a brief description of what you want to do, and then click Go. So I'm going to click, I want to solve for future value. And the second thing that appears on the list is FV, which sounds like an abbreviation for future value. So I click that, and for our problem where you had $100 a year for 3 years, well, I know my payments are $100. Just to be a contrarian, I'm going to make it a negative $100 because in essence, the money is being paid out. So it's a negative outflow. So negative $100. It's being paid for 3 years, and the interest rate is 6%. Now I can type 6%, or I can also type 0.06. Either one works. So I'm wondering what that's going to be worth as a future value. Present value is 0, so we're going to leave this blank. Type, we're always going to assume that type is blank because payments are being received at the end of the period. If you leave it blank, it means payments are at the end of the period. That's what we want. So everything else is fine. We click OK, and it says that 3 payments being paid over the course of 3 years are going to be worth $318.36. What this is telling us is $1 today is not the same as $1 3 years from now. $300 today, or not really today because it was actually staggered over 3 years, but $300 being paid out in earlier time periods is actually worth $318 and some change in the future. So this shows you, you don't have to do a lot of calculating. All you have to do is to plug the numbers into Excel, and it shows you, immediately what the values are. Our $100 at 5% interest for 1 year can just as easily be solved on Excel. We can put in, again, just open up the FX box. It's once again a future value calculation. We can say 5% interest, 1 period, present value was $100, and we're wondering what the future is going to be, or the value is going to be in the future. It says negative 105. The reason it says negative is the present value and the future value will always be opposite signs. So if we put a positive number in as our present value, that means it's going to be a negative number for the future value, and vice versa. Don't get hung up on the signs. The idea is $100 today is worth $105 a year from today at a 5% interest rate. As long as you remember that, you can just neglect what the signs are. Okay, now, this is very, very straightforward. What about present value? We've kind of alluded to the fact that we can do simple math to figure out what the future value is going to be. There's actually a formula for all this. 1 plus the interest rate to the power of the number of years times whatever you're investing will give you the future value of what you've invested. Okay? Present value is basically virtually the reciprocal of that. It's the amount of money that you're investing over 1 plus the interest rate to the number of periods you've invested. So instead of multiplying your investment by this, you're dividing your investment by that. And that's the math behind the present value. Thankfully, we don't have to memorize this and we don't have to use this. We've got Excel, and Excel does all these formulas for us. So, what would happen if we had a timeline? We were going to receive $5,000 in the future, and we're wondering what the present value of that is. It's 4 years in the future, and the interest rate is 4%. So what's $5,000 4 years from now worth today? We'll solve for the present value. And I'll once again move the flip chart so you can actually see the screen. We go to FX. This time we choose PV, present value. We know the rate of interest is 4%. We know that we're going to receive the money 4 years in the future. The future value is going to be $5,000. The present value, 4 years away from when we receive it, is only $4,274. So the bottom line is we have the choice of $4,274 today or of $5,000 4 years from today. At a 4% interest rate, we're ambivalent. We don't care which we get. $4,274 today is the same to us as $5,000 4 years from today, as long as we know we can invest our money and get a 4% interest rate. We basically don't care which we receive. That equates present value to future value. Now, all of a sudden, the problem that we had with regards to buying a house seems a little bit easier to calculate. If we do our timeline, we're solving for the payments. That's what we don't know. What we do know is the house is going to cost us $200,000 today. We know that it's going to be paid off, it's going to be zero after all the payments are made. We know the interest rate is going to be 4.125%, and we know that it's going to be over the course of 30 years. However, when's the last time you paid for a house on an annual basis? You don't. You pay for it on a monthly basis. Well, that means we need to change two variables. We need to divide the interest rate by 12, and we need to multiply the years by 12. That puts the periods of payment on a monthly basis, and it puts the interest rate on a monthly basis. Now we can figure out what the overall payments on the house need to be. Once again, I'll disappear. So we go to, let's clean this up. I've got too much noise here. Okay, we go to our FX button, and we're solving for payments. Well, I don't see payments, so let me type that in here. Payments. Oh, PMT, that must be payments. So we know what the rate is going to be. It's going to be 4.125% divided by 12. We know what the number of periods is going to be. It's going to be 30 years times 12. We know what the present value is. We'll make it a negative number since we're paying for the house. it's negative $200,000. Future value is going to be 0, so we'll leave that blank. Type is going to be blank. We hit OK. That $200,000 house is going to cost us $969.30. So that's our monthly payment. Not counting taxes, not counting insurance. We're going to pay $969 a month for a $200,000 house. All the mystery of what the real estate brokers do now gets cast away. You can see how they compute what your monthly payments need to be. And it's just a few strokes in Excel. What about if you're buying a car? Exactly the same calculation. You decide that you want to buy the newest car you can find. So you get yourself a car that costs $28,000, has all the accessories you're looking for. That's $28,000 after the down payment, or whatever you paid as a down payment. So it's $28,000 that you have to borrow from the bank. They're charging you 6.9%, and it's going to be for 4 years. Now, this is the exact same situation we had before. It's not an annual payment, it's a monthly payment. So we're going to divide this by 12, and we're going to multiply this times 12. So 4 years times 12 is going to be 48 months. 6.9% divided by 12 is whatever that ends up being. $28,000 is the present value of the loan that we're getting from the bank. What are we solving for? We want to know what our monthly payments are going to be. Okay. Once again, we go to Excel. We say, all right, in FX I'm going to solve for payments yet again. I know my rate is going to be 6.9%, and on a monthly basis that'll be divided by 12. I know I'm going to pay over 4 years, so I'll multiply that by 12. My present value is going to be negative $28,000, negative because it had to be paid out. And I'm wondering what my monthly payments on that really nice car are going to be. Wow, I've got to pay $669 on that car. So that is not going to be a cheap car. That's 2/3 what I have to pay for the house. So I'm paying $900 and change for the house. I'm paying $669 for the new car. So that's quite an outlay of cash. All of this is wonderful, but there's one button you cannot find on Excel, and that's the infinity button. There is something called perpetuities. And a perpetuity basically says that you are going to receive a payment of a certain amount of money forever. They're not popular in the U.S., but they are popular in Europe. And it's not unusual for them to say, okay, you'll receive a coupon on this bond. Say the bond was paying $4 a year. You will receive $4 a year forever. And the question is, what is that worth? Well, the easy way to compute that is to say, what is the going interest rate, the long-term interest rate in the economy today? And you say, well, the long-term rate is 2.5%. So you say, okay, $4 divided by 0.025. And you say, oh, well, I think I can calculate that. So you go to Excel and you put in the formula equals 4 over 0.025. And you say $4 a year forever is worth $160. So we've suddenly put a value to an infinite string of payments. That, in its most simplistic form, is the way that we compute perpetuities. It's the amount of cash that we receive each year divided by the current interest rate. And if you do that, you can solve any perpetuity. That's it for this part of Chapter 4. We're going to have a little bit more, but I'm afraid I'm running out of time, so we're going to split this into a second half. Thank you.